All right, well, it is 9:40, so, or 9:41. We're gonna go ahead and get started. I'd like to welcome you again to IMSAtute Day and the conference in general. My name is Lindsay Hurley, and I am a curriculum specialist at the Illinois Math and Science Academy. And today we are going to take a look at some STEM skills for success, really focusing on the math part of it, so young mathematicians. I have the privilege of talking to you about this today because the world of young children in mathematics is extremely important. This is listed as a K2 presentation, but I know that I have a few of my early childhood teachers in here as well. And these concepts that we'll talk about today apply to preschool through second grade, but also the big foundations that we'll talk about really apply to K5 and beyond. So I'm happy to be here with you today, and I am excited to share and hear some of the things that you're doing in your classrooms. And then, of course, everything that we do talk about will be available for you to download. So a few things to take a look at today. Our first objective for this session is to think about your own journey as a mathematician. Math is a very emotionally charged subject when it comes to education. There are people that love math, and then there are people that absolutely despise math, and that goes from children to parents to even teachers. And it's all about the experiences that we had as we were growing as young mathematicians. So we're going to think about our own journey. We're also going to take a look at some of the big ideas of mathematics. Early childhood mathematics, K2 mathematics, really is just foundations of what math is in general. And we're going to take a look at what this looks like. There's different activities we'll see that are appropriate for both the physical classroom, a virtual classroom, or anything really in between. We're also going to look at some STEM applications that integrate these foundations. STEM skills require students to be problem solvers and flexible and efficient and have the confidence to take risks. And these are all things that we teach children and explore with kids as they're engaged in mathematics. So we see a really good integration between what we're asking kids to do in STEM and what we're asking kids to do in just the general subject of mathematics. So we're going to start off, and if you would be so kind to kind of put in the chat, what is your math story? So if I were to set up a poll and ask you, what's your math story? Where are you on this spectrum? Would you say math is my most favorite thing? I love doing math. Give me all the math problems. Or would you say, I mean, I'll do it. Like if you ask me to, or if I have to teach it, I'll do it. Or are you like, no, thanks, not interested, terrible experience. So go ahead and take a second in the chat and you can kind of tell me your feelings. What's your math story? Where are you at on the spectrum of mathematics? Okay, math is not my favorite thing, but I don't hate math. Okay, good. So kind of a middle of the road there. If I had to put in, I would say that I love math, which is kind of funny for me because my experiences are very different than the experiences that my daughter is having right now. She is in kindergarten, and I watch her experiences with math, and the way that she is doing math is totally different than the way that I did it. In real life, math's a struggle, but in the class, you love it. Good, when you're teaching lessons. And that's great because I'm sure that your students see that, and that is their perception as well. And that always helps when the teacher is also excited about it and when they're working with the students. Good. All right, very nice. Well, when we kind of do this in a more general setting with educators that may be more math focused than not, we see that math educators tend to like math, and that's a pattern, a trend that we would expect, while others say that they don't enjoy math. There's been a lot of talk about this math brain. And even when I was in my previous experience as a math educator, I worked in a middle school, and the number of times that a parent would come into parent-teacher conferences and just say, yep, I mean, I can't expect them to do well in math. I'm terrible at it. If I had $1 for every time I heard that, I would not be teaching anymore. But it is a math story, and our math stories are curbed by our experiences in school. So when we think about this math story, I want to share 2 resources with you that are really important. I am not a big book study person by any means. I just don't have the time. I have 3 little kids, but this book is excellent. If you are not familiar with Tracy Zager, she is a wonderful resource and professional development coach for math educators. And this book is it's a page turner. She does a great job of really breaking down what it means to be a math teacher and addresses some of the more emotionally charged pieces of what it means to teach mathematics. But in her story, she shares some really interesting quotes that I want to highlight. And her idea is that we need to start teaching mathematics and not math class. So these are 4 different quotes that came from elementary students, so K2 students, K5 students, and they were asked, what is math? And here are some of their responses. And in a time where everything's already very difficult, I don't mean to make this even worse, but here are some of their responses. Math is when you are given a sheet of paper and it has a problem on it and you just don't get it. That's so depressing. Being good at math means that you answer the teacher's questions fast and right and easy. And that is so common. You ask students of any age, what does it mean to be good at math? Or really, what does it mean to be good at school in general? Oh, you get all the right answers and you get them really fast. You raise your hand the most, you know all the answers. Math is when you have sheets of paper and it has math on a board, and it's learning how to write numbers, learning how to write math. That's what math is. And the only way to learn math, this is the most depressing, is to be taught by someone that knows more than you do. So the only way that children can learn math is by having a teacher or an adult or someone older than them that knows more tell them about it. And we know that that's not true. We know that young students, infants, begin exploring concepts of mathematics at such a young age, and they do a great job of that initially through play. But these are some perceptions of what mathematics is that we really are going to work hard to change. And especially as educators that grew up in a system that we are now trying to change, that's a tall order. That's a challenge for us. But we really need students to start understanding what being a mathematician is and be less worried about being good at math class. So that is a huge message in her book. And like I said, it's worth the read. I highly, highly, highly recommend it. The other resource I wanted to share is by NCTM. It's called Catalyzing Change, and they have 3 different books. This book is for early childhood and elementary mathematics, and it really does a good job of breaking down pieces of mathematics and looking at the foundations. But again, even at a national level, NCTM is seeing the same problems that Tracy Zager was in her book about how children are perceiving math. And what they say is that children don't see themselves as naturally capable of doing math. And when they think about what a mathematician looks like, they see the same character, pictures of old, disheveled, bald white men wearing glasses, working alone and writing equations. And I can tell you firsthand that this is true. This is also how children see scientists. If you ask your kids to draw a scientist, they will draw a old white man, sometimes wearing glasses, in a lab coat, probably holding something that's exploding. That's how they see scientists. And we need to work hard at taking apart this perception. And it's important when we think about equity in mathematics, we need all students seeing people that look like them, that sound like them, doing mathematics and being successful. So This is something that we need to work towards. So with these things in mind, we're going to kind of see where do we go with this and how do we address these needs. In Catalyzing Change, there are 4 key recommendations that NCTM put out. I'm going to really focus on this develop deep mathematical understanding today. And what we're trying to do with our students is when we think about math foundations, these are the strongest parts of math. So if you were to boil down mathematics into the key concepts, that's really what we're going to focus on today. And the reason that these are foundations is because, again, they support mathematics from preschool, from pre-K to kindergarten to first to second, all the way through what students explore in AP Calc, AP Stats, some very, very high level mathematics. And the way that we do that is by thinking about, again, not math class, but what mathematicians do. They reason, they make sense of problems, they try to solve problems in a variety of different ways. And that's really where we're going to go today. All right, so here are the foundations of early mathematics that we're going to take a look at. The way that this presentation is set up is we're going to talk about just kind of some of the pieces of each. So if you had to know what are the most important parts, biggest ideas of these foundations, we'll discuss that. And then for each foundation, there are at least 2 examples. Some of them are more math heavy, some of them are more integrated. And these are for you to take back to your classroom. They are very easy activities to do that require very little materials that are not common in a classroom, that the goal is just to start exploring with your students. So these foundations are kind of a summary of the ones that are listed in both NCTM's Catalyzing Change. And then the other resource I wanted to share with you, and I'll put it in the chat because it is absolutely fantastic, is Erickson Institute's Early Math Collaborative. They are a Chicago-based organization that supports early childhood math in amazing ways. It is truly impressive, the things that they put out. They have great free PD resources. So if you are looking for ways to continue to engage in early childhood math, they are definitely worth the time to check out. So today we're going to look at sets, number sense, counting and operations, measurement, patterns, data analysis, space, and shape. And you'll see as we go through these, a lot of them connect to each other. The thing about mathematics that we know is that when you look at one part of math, there's also at least 2 other parts that are connected in some sort of way. So with that being said, the first activity the first foundation we're going to look at is sets. Now sets are really thinking about attributes, and attributes are important both in mathematics, but also in science. If you think about the ways that scientists identify objects and materials, organisms, it is by their attributes. So what we want students to explore in early childhood and elementary math is the idea that attributes can be used to sort collections into sets. Sorting is a really important concept and skill when we talk about sets. We want them to understand that items can be sorted by the same way or different ways, depending on what that attribute is that you are most interested in. And then of course, we can compare and order sets. So the first example that I wanted to share with you is called a sorting station. Now in an early childhood classroom, this could be just a table that you have. In a K2 classroom, I'm always a big fan of having a math table. Those tend to be more common in the early elementary years. I always also really encourage my middle school teachers to have a math table because it's amazing when students are given the opportunity just to freely explore something that doesn't come with a huge set of directions or expectations, they tend to go for it. But a sorting station can look like this. You'll notice that on this sorting station here, there's a collection of items. They are a random assortment of items I see different colors, I see different shapes, I see different textures. And then you see that there are some 3 sorting mats. Now, do you have to have this type of thing? No. However, it does help to have that contrasting color and a place, especially for students that are really just beginning to get confident in sorting, places to put their items as they sort them based on their attribute. Now, when we do sorting, one of the things that we talk about is the 3 Ds. So the first thing that students just do when they decide or do a sorting is they decide how they are going to sort. Students tend to pick a attribute that is most familiar or personal to them. So they decide how to sort, then they do the sorting. And then the most important D, if you ask me, is they have to discuss. So the sorting does not end once all items are sorted. One of the most important parts is to talk about how those items were sorted, not only because that gives students a chance to verbalize what is in their head mathematically, but also gives you a great idea as the teacher how to assess what they're understanding. So I kind of put below this image a variety of different things you could have students sort. You could have them sort number representations and operations, different kinds of cards, different math manipulatives. If you are looking at the science part of it, you could have them sort different images of organisms. There is very little boundaries when it comes to items that kids can sort. And the great thing about it is you can differentiate it very easy. For your younger students that are just exploring sorting, maybe they sort by color, a very somewhat primary type of mathematical thing to do. For other students, maybe they sort on whether items float or sink, or the category where they can be manipulated to do both. There's a lot of things you can do here with sorting, but a table to sort is a great space to have in your classroom. The next resource I wanted to share with you is called Which One Doesn't Belong. If you are unfamiliar with Which One Doesn't Belong, I'm going to put his name in the chat. Christopher Danielson is another great educator, math specialist, and he put together a resource called Which One Doesn't Belong, which has both a website and he has several books out for Which One Doesn't Belong. These resources are great because they are based on pre-K through high school level mathematics. And the goal here is just to increase math talk, to give kids an opportunity to talk about mathematics in a very non-threatening way, where multiple answers are always the correct answer, which when we can have students engaging in those activities, that's a great way to be a mathematician and not engage in math class, okay? So the first one, I want to kind of show you how this works. These are really fun to do. They're always my favorite. I'm going to start with one that would be great for a preschooler, for a kindergartner. So here's an image of dominoes. You see 4 different dominoes here. And the only question that I have for you is which one of those doesn't belong and why? And if you could just enter your thoughts into the chat, you can call them by top right, top left, bottom right, bottom left. Which one of those dominoes does not belong and why? Top left, it's the only even number. Okay, let me move the chat and see this. Excellent. Okay, so when you add all those together, you see that the top left is equal to 8 and the rest of them equal odd numbers. Excellent. That one definitely does not belong. Double 4s, the rest have an even and odd number. Okay, good. So top left also doesn't belong because it's the only one that includes 2 of the same numbers. Also very correct. Bottom left, because there's no dots on the bottom. Yeah, that one's like naked, totally missing its dots. It does not belong. Very good. Any others? I might say the top left also doesn't belong because it doesn't include like the dot in the middle. There's no dot in the middle on those for some reason. Others have like that 5, that 3, and that 3. That one doesn't belong. All right. So that's just it's just an exercise. It's a really quick way to get kids to talk about mathematics where there is really no single correct answer. There could be wrong answers if the justification is incorrect, but here we're really encouraging kids to just talk about mathematics in the way that they see math, which we know for everyone is different. So in an older classroom, perhaps a second grade classroom, a third grade classroom, here's another example. So these are looking at various representations of multiplication facts. So if I look at these, or fact families, when I look at these, which set doesn't belong? You could say green, blue, orange, or yellow. Which one does not belong? Top right, only addition. All right, good. So in this problem, I see it represented by 8 plus 8, and the rest of them are multiplication problems. So that does not belong. Blue, because of addition. Good. Any others that don't belong? Excellent. Bottom left has no 8. Yep. 4 times 4 does not belong because it doesn't have an 8. All right, excellent. I like how Kate took a look at the way that they were also grouped. And I did too. Okay, good. So Sarah has what I was thinking. So she had the yellow doesn't belong because it's represented with manipulatives that are circles. I would have also said that it doesn't belong because those manipulatives are arranged in a vertical pattern while the others are arranged in a horizontal pattern. All right, so just some ways to really think about the way that math looks. And again, there's tons of resources out here. It's also easy to make your own. Pick 4 items, put them together, take a picture, put it on your board for kids to talk about. Very simple, low cost, high reward activity to look at attributes while also looking at several other math foundations. All right, so that's what we have for sets. The next one is patterns. It's appropriate to go from sets where you look at attributes to patterns, where everything is written on a rule based on attributes. So patterns are sequences we know that are governed by a rule. They exist in both the world and math. So once again, that integration between math and science, we see patterns in math all the time. In fact, sometimes when you say the word pattern, to many people, they think, oh yeah, like blue, green, blue, green, blue, green, or ABC patterns or ABB patterns. But patterns are everywhere. They're beyond these basic patterns that we have in math class. We see them in the world everywhere. Patterns allow us to have predictability in a series of events. We're able to make generalizations about them, and we can find them in different forms. So the one resource that I want to share with you, which is a great informational text resource. I love having these in classrooms. I will tell you that one of my favorite things to do with informational text like this, and my English language arts teachers cringe when we talk about this sometimes, but is to completely rip the book apart and laminate pages or put them in sheet protectors, because then that allows me to distribute the pages to students, and then everyone can kind of take a look at everything the same or at the same time. So remember, that's always an option. No one's actually going to come after you. So this book that I have for you to share really touches on the sciences of what patterns are. Patterns in Nature, written by Philip Ball, is a beautiful book about patterns that we see out in the world. And here's an example of some of the images that he has. We see patterns in animals. We see patterns in weather. We see patterns in the seasons. We see patterns a lot of places. Every day, the sun comes up, goes down, the moon. We see the sun and the moon. I don't want to say the word alternating because that's kind of a misconception in science, but day and night, perhaps. We also see seasons. Seasons are a regular pattern that we see. Students have patterns in their everyday life. They get up, they brush their teeth, they go to school, they come home, they eat dinner, they take a bath, they go to bed. There are patterns in lots of places. In nature, we see examples here, patterns in spider webs. We see patterns in lots of weather. In this book, you see images, great images of tornadoes, of the eye of a hurricane, of lightning strikes. Also bubbles. You can see here the hexagon shapes of the honeycombs. So there are patterns a lot of different places, and this book does a great job really highlighting what those are for students to consider. The next activity that we do in patterns, and this is also one of my favorite ones, we have this in our early childhood curriculum called Little Steamers, which I know Sarah, who's here with us, she is part of. But this activity is called What's the Error? So I talked a little bit about students get a lot of exposure practicing patterns that are A, B, A, B, A, B patterns. They extend the pattern. They find the missing part of the pattern. But one thing that we can do with kids that's actually a lot of fun, and students enjoy this because they love nothing more than correcting an adult, is to put an error in a pattern. So this kind of ties in the science idea of computer science and coding. One of the most important parts of being a scientist and a mathematician is to be able to evaluate a problem, identify the issue, or troubleshoot the pattern, and find a correction. So here's an example. These are just items that I had around the house. Imagine doing this in your classroom with all those manipulatives that you have in your closet, in your shelving. So what I did here is got some sticker dots. You see there is an A-B pattern between orange and green, and the student has to identify where the error is in the sequence and replace it. They have to identify it, talk about it, replace it, then with the correct manipulative. And this is just another great way to have students practice what patterns are beyond the typical extend, find the missing part. They really have to have that knowledge of looking at the overall program, and troubleshooting, or what we say in coding is debugging. And what I like about this too is that it doesn't always focus on the end of the pattern. When we have kids extend a pattern, they're really looking toward that end piece. In several of these examples, I put the errors at the beginning of the pattern, which really throws off the kids because they automatically assume that whatever the pattern starts with has to be the correct sequence. And then the error is at the end. That tends to be what I notice when I do this with kids. So give them some mistakes to think through. We love the what's the error. It's a great way to practice patterns with kids. All right, the next foundation that we have, and I want to say that all foundations are important. However, number sense, I would argue, is by far the most important foundation. And the reason that I say this is, first of all, I told you about my history in middle school mathematics. I can tell you that the students that struggled with math, it was primarily because their number sense was so weak. If you talk to your middle school and high school teachers, they will tell you the same thing. So for my early childhood teachers and my elementary teachers, we bow to you because you are the makers of number sense. We rely on you and we respect you because you have a very, very important job when it comes to building number sense in kids. Number sense is all about using numbers in math flexibly and efficiently. And we'll talk about what that means. But we want students to be able to use numbers in lots of different ways. We want them to understand the concept of quantity, that quantity is used to name a specific amount, and that what we're really looking for here is this concept of Stubitizing. Stubitizing is not a new idea. Stubitizing has been around since like the 1950s. However, it's recently become a hot topic in math classrooms because it is so important. So we're going to spend some time, and in my next session, which is in the session after this, we do the entire hour on Stubitizing and what it means to build number sense. So if this is something that you feel like interests you, or you have room to take in some new information, I'd encourage you to join me for that session. But to understand what Stubitizing is and how it builds number sense, you have to do it. So I'm going to show you 3 images. They're going to flash on your screen. They're going to be super quick. So you got to make sure you're paying attention. When you see these 3 numbers in the chat, if you would then enter in the numbers that you see, that would be excellent. Okay. All right. Yeah, a lot of resistance for Stubitizing. Yeah, sometimes, and I don't know, Sarah, if that means that it's because they don't see the value in it perhaps, or they don't really know how to work on it, or there's lots of different reasons, but it is important. So we'll take a look at a couple activities today and really think about why it's worth our time to do with students. But like I said, so 3 images, take a look at them. They're going to be really quick, so you got to pay attention. All right. So the first thing I'm interested in is, what do you see? All right, those were very fast. Go ahead and enter what those numbers were in the chat box, if you would. Good, good. 425, excellent. All right. 425, good. All right, good. So that was absolutely correct. You saw the number 4 and you saw the number 2 and 5. So we start off with a 4 die pattern. We started and then went to a 2 finger pattern and a 5-10 frame. All right, excellent job. So my question is then, these went so quickly on your screen, how did you know what they were? You did not have time to count them, surely. So how did you know what those numbers were? You also noticed that they were different representations of numbers. When we build number sense, we want to make sure our students are seeing more than just numerals. They need to see 10 frames, number representation or finger representations, tally marks, rec and rec sets, die patterns, all those different ways that we represent numbers. All right, good. So use them all the time. Brittany said that she saw a double, a 2, and a 2, so she did some grouping there. Great job. And these are very common responses. We know as adults what those numbers were because we have practiced them so many times that we're familiar with them. We instantly are able to perceive that number without counting. And this is something that we need to work on with our students. And the reason for this is because when students then go on to higher level mathematics, and by higher, I mean like only kindergarten, 1st or 2nd grade, is they are able to take images of quantities in their head and manipulate them, which sounds extra. It sounds kind of like what people say, like they diss Common Core about. However, these images are so important to developing true math strategies that are much more flexible and efficient than simply memorizing or counting linear quantities, like linear sets of numbers. And to see an example of that, you'll have to join me in the next session. I really go through and talk about what Stubitizing looks like for even a 2nd grader. So it's really a valuable practice. Okay, good, yes. Smaller numbers are easier for your brain to quickly see. And I'll just tell you why really quick. There are two types of Stubitizing. The first type of Stubitizing is called perceptual Stubitizing. And that is where students are practicing only numbers from like 1 to 5. And that is because they require hardly any grouping strategies. The doubles, the 2 sets of 2 were mentioned, but many students, when they have practice with Stubitizing, they instantly see that as a 4. Perceptual Stubitizing is what early childhood kindergartners and some 1st graders are working on. The second type of Stubitizing is conceptual, and that's where you use strategies such as grouping. So that's where like 6 starts, because 6 is sometimes seen as 2 groups of 3. And I know that 2 groups of 3 equals 6. So that's why, yes, quick looks, absolutely. I call it flash it, just like I did here. But that's excellent if that's part of your math program, because in many it's not. So yes, 2 different types of Stubitizing. And you know, some kids, even your 2nd graders, if you're a 2nd grade teacher, you might have some kids that are still trying to Stubitize perceptually from 1 to 5. And you might have kids that are conceptually Stubitizing up to much larger numbers. And it is an individual thing. We say that number sense can't be taught. It is caught. And the only way to catch number sense is by continuously being exposed to it and practicing it. You can't teach number sense. So how do you teach number sense? How do you provide opportunities for your kids to catch number sense? And I will tell you, in terms of Stubitizing, sometimes you need to give your kids permission to Stubitize. I do this with my daughters all the time. I have a 6-year-old and I have a newly 4-year-old. And with the 4-year-old, we practice Stubitizing by playing board games all the time. And it took a while for me to tell her, you don't have to count the dots every time you roll a die. If you know that that's a 4, Maddie, you can tell me that's a 4. And it's not to say we don't want to teach kids counting, but counting individual items is not efficient. And at some point, we need to make the connection from that counting piece, which at a certain point becomes inefficient, to Stubitizing, which is much more efficient. So if you notice kids doing it, you might just have to give them permission and let them try it out a couple times. All right, so activities. Small group and partner activities. One of my favorite resources that I like, because it provides endless options for what to do with Stubitizing, is Tiny Polka Dot. It is a game. I tried to, give you a variety of different materials in these examples. Tiny Polka Dot's one of them. I checked this out at my local library. You can purchase it off of Amazon, but it's free at your library. You can check it out for a couple weeks and let the kids play with it. And you can see here that this game comes with a variety of representations of numbers. There are numerals, but then you see a 10 frame there. You see them arranged in a circle. There are die patterns for students that are practicing or putting together and taking apart numbers. You see cards with the green and the blue dots. There are lots of possibilities here. And then the cards that you see that come with it, those are different games and exercises that they recommend using the cards with. So there are some things there for you to check out as well. That is just one resource there. But any game that you play that has just regular cards, whether they be like a deck of cards or numeral cards, you can sub those out with Stubitizing cards. You can play memory with Stubitizing cards, where you have different representations of numbers and they flip them over and try to remember where they are. You could play war, so different representations of numbers and same rules. Whatever one is largest wins, whatever one's smallest wins, you can decide. You can do that. Quick flashes, flash it, lots of different things you can do here in small groups. Again, even if you're in a classroom where you don't perhaps have that small group math all the time, have that out as just a resource during exploration time, to use during transition times. Lots of different ways that you can integrate this. The other one that I would like to encourage is Stubitizing cards. So I have 4 different sets here. These would be appropriate for different grade levels. The most, like the initial Stubitizing cards, which would be appropriate for early childhood kids. Christina Tondevold here, which are listed under the Savvy Stubitizing card. She's also a great PD resource. She is all about number sense in pre-K through 5. She holds free PDs constantly, and she's wonderful. This is a resource that she has. You can actually download these cards and print them off and use them in your classroom for any of the activities that we just talked about. For my 2nd grade teachers and around 2nd grade, Graham Fletcher another great resource, has multiplying stubitizing cards. So again, why are we teaching stubitizing? Because we can do it all the way through multiplication. So here you can see that there are 7 groups of 3. So kids can go through, and this is a good job bridging between using a manipulative to see groups of, and then seeing just the problem using numerals. This is a good way to kind of bridge that together. There are also, I like these, I do these with even my preschooler and my kindergartner, just fun stuff, geometry stubitizing cards. And these are very versatile. So I can ask them, how many did you see? And they could say, oh, I saw 5. Or they can give me more details. I saw 5 shapes. I saw 4 squares. I saw 1 circle that was in the middle. Good way to practice different shapes and properties of shapes and orientations. And then the last one there is fractions. So different way to recognize fractions. Fraction stubitizing cards, which is also a Graham Fletcher one. These are all free. All can be downloaded, all free. I have a resource guide I'll give you at the end where you can download all of these. But they're great to have in your classroom for a variety of different things. Even if you have like those, 5 minutes where you're like, the kids are kind of getting crazy and you're waiting for that time to pass between now and when you do your next thing. It's always a good thing to take out and, make use of that time. All right, so I also wanted to show you this number sense video. So this is another one of my great way to include stubitizing in your practice. I love this because it is an easy material that can be manipulated for preschool through 2nd grade. So go ahead and take a look at how this teacher is using this tool. Whoa, that's cool.
Okay, my friends, so to go to gym today, I'm gonna have you tell me how many dots you see. Are you guys ready? Leon, do you wanna go first? Okay. Okay, show me how many. Oh, I see that you showed me 3 fingers for 3 dots. Go ahead and go sit by your locker. Okay, show me how many. Yeah, I like the way you showed me 3. 3 fingers for 3 dots. Okay, Arnold, are you ready?
I didn't see you.
He just got here. Okay, Arnold, you're going to show me on your fingers how many. Are you ready?
Arnold, did you see you?
I see that you showed me on 2 hands. You showed me 2 and 1. That is 3 for the 3 dots. Go ahead and go to your locker. Jordan, are you ready? Okay, show me how many. Oh, good try. You showed me 4 fingers. There are 2 dots. Go ahead and go to your locker. Okay, King, are you ready?
All right. So with this video, I like this tool because it is so easy. It's a binder ring with index cards that have sticker dots on them. It really doesn't get any easier than that. And what she's doing is she's having the students look at an image and then replicate it using their fingers in some sort of way. What I like too about this is that you can easily make this, and it can work for kids that are on a variety of different levels stubitizing. You could have cards from 1 to 10. And for your students that are really working on those 1 through 5, they can, that, and you can choose numbers that either, work on what they're practicing or slightly challenge them. For your students that are higher in their stubitizing abilities, they can work on the numbers, from 6 to 10. You saw that the teacher also acknowledged the student that showed that number on 2 hands. You can encourage them to show me it on 2 hands. You can switch it up, say, show me 1 more than this number, or 1 less than this number, and they have to think about it. But again, a really easy tool to just have as a teacher, and it's just made of index cards and sticker dots. Very, very, very simple. All right. The next math foundation that we have is counting and number operations. So here we're thinking about how many are in a collection and comparing, ordering them, thinking about how they can be decomposed and composed. The first example that I have here is in what we call an estimation station. And I love this because Estimation is so important in mathematics. It's cheap and easy. Anyone can do it. It is kind of like making a prediction in science. It is what needs to become just a natural part of doing mathematics that often we look over. And then when students get to middle school and high school, they make crazy mistakes in their mathematics and they have no idea that that's wrong because they have no sense of what's reasonable versus what's unreasonable. What I like about the estimation station is that it gives kids a benchmark visual. So often when we have students practice estimation, we take a jar that's see-through and we put stuff in it and we say, how many do you think it is? And for a student that is developing the visual of quantity, that is a really hard question to answer. So with the estimation station, I like this because it shows the students what 2 looks like, what 3 looks like, what some quantity looks like, and then a number that is too high, like 10. And so students are able to kind of use that guide to start confidently building estimation practice. And this can be used, again, with really young students. Perhaps they're practicing estimating to 10, or older students. Here is what 10 looks like. Here's what 15 looks like. Here's what 30 looks like. What could be that number in between? So lots of different ways to use that to practice estimation. The other activity that I have that I like, if you are unfamiliar with 3-act math tasks, that's my 3rd presentation, which is in session 4 after lunch. There are some great 3-act math tasks that really look at counting and number operations. And what 3-act tasks do is they show students a visual. It's usually as like a video. And it's intriguing to kids because sometimes it's like strange because you haven't seen it before. But the goal is to have students watch this image and ask a question about it. We want students asking questions in mathematics. So here's an example of this video. This is called the Pringle Wringle. I had no idea you could do this. I was amazed at this video. I wish I would have seen it during like quarantine when you had literally nothing else to do and you were just sitting around looking at each other all day, because this would have been a great challenge. Whoops. All right, check it out. I mean, did you know you could do this? It's amazing. But the question here that students think about is, well, how many Pringles did it take to make that? It's called the Pringle Wringle. And so students watch that video, they think about the question, how many Pringles did it take to make that? And then they think about, well, what information would I need to know? I'd need to know how many chips were in the container that he opened, and I would need to know how many were left. And then I can do some basic number operations to figure out how many it took in order to build that. And that's what 3-act math tests are all about. Seeing an image or a video that sparks interest is embedded with a mathematical question that students then have to think about, well, what do I need in order to solve this problem? And it becomes just much more impactful and touches on some of these math foundations. The next foundation is measurement. So we can do measurement using a variety of different tools. And remember that measurement is not just about length, width, and height. It's also about things like time, capacity, volume, mass. So lots of things for students to explore here. And we also want them to have the opportunity to explore using a variety of different tools, standard and non-standard tools. One activity that we use, again, in our early childhood program is we have students in their block center where they create ramps naturally, like every single day. They take that one step further and they then quantify how far their car has traveled. So sometimes it's as simple as looking at what students are already doing or playing with and adding in very intentionally that measurement piece, showing them where we can take it one step further and really think about some cool things here by introducing the mathematics. So in this example right here, you'll see students, they send a car down a ramp and they see how far it has traveled using Legos as a measurement tool.
What do you think it's going to travel?
I think it goes down to 5 or 6.
You think it's going to go farther than 6? Okay, well, let's see. Let's measure. All right. Okay, great. Let's measure and see how far those cars traveled.
I apologize, my video is getting a little jammed up here, but the students measure and then they figure out how to use that in order to quantify how far that car has traveled. Okay. Another example is Exploration Center. So here we have a student and he is filling up containers of various sizes and shape with pom-poms. You could sub out a variety of different sensory materials, water, sand, pom-poms, little Unifix cubes, lots of different things, and he is exploring capacity. We do a lot of pouring and filling in early childhood classrooms to practice that gross motor and fine motor skill, but adding that blue tape that you see, that is for students to fill to a certain point. So really thinking about that capacity part. All right, the next math foundation that we have, and I'm going to kind of speed this up a little bit because I want to make sure to give you time for questions if you had any, is data analysis. And young students are completely capable of doing data analysis. What we're interested in here is we want students to understand that math can be, or questions can be answered with mathematics. One of the best ways to do that is a good old conduct a survey. We love these. We've been doing them for a long time because they're actually really valuable. This is a good one to keep around. Have students ask people things that can be answered with math. It's a great opportunity, not only for practicing the math skill of recording data and organizing data, building in some Stubitizing with those tally marks, but also public speaking is a great thing for our younger students to do. The other one is tables and graphs. So I really like this activity. What we do here is we give students cards. Half the cards have a table on them of information. You see those on the right-hand side of the screen. And then on the other half of the cards have a picture of a graph of some sort. And you'll see that the graph is missing labels. And what students have to do is look at the tables and match them up with the appropriate graph. And this is a great, we do this activity in our elementary, middle school, and high schools. There are so many of our high school teachers that do this with students the first week of school because their graphing skills have gotten sloppy. This is also very adaptable for preschool teachers. You could have them work on looking at numerals and matching them up with pictures of Unifix cubes together. For my older my teachers of like my second grade students, you could have pictographs, you could have the Unifix cubes, and you can have bar graphs. Lots of different representations of numbers that we really like. And then finally, we have spatial relationships and shape. And this is more than just understanding what a square looks like, what a rectangle looks like. It's also understanding how objects are situated in space. So that ordinal position, and honestly, one of the best ways to support this beyond looking at geometry is having kids do puzzles. Puzzle making is a really important skill and touches on so many mathematical concepts, and that's often overlooked. So I am a huge fan of puzzles. We have so many puzzles in this house, it's ridiculous. I'm sure like half of them are probably missing shapes or bent or whatever, but love puzzles. When we look at activities to do, attributes of blocks are a great one. So if you have these wooden blocks in your classroom or around your house, this goes back to sorting again. Looking and understanding that a three-dimensional shape also contains two-dimensional shapes. So what students have to do in this activity is they take a block, a three-dimensional block, and they have to sort it based on if it represents rectangles, triangles, circles, or squares. And this is a really hard activity for some kids because many of the three-dimensional shapes contain more than one type of two-dimensional shape. So if students are working in a group, they have to come to a consensus. Where am I going to put this prism that contains not only a rectangle, but also a square? So they have to kind of think about that and make some choices. But that's a really fun one to do. And then lastly, integrating that science piece again. Mathematicians and scientists do more than write reports and write down numbers. They do a lot of drawings. And drawings are very, very important, especially they are very rewarding for building that spatial relationship and shape concept that we're working on with students. So students can draw properties of shape, they practice orientation, they think about, use their senses to explore. In a lot of our programs, we incorporate observational drawings because they are a huge part of what a mathematician and what a scientist do, which takes us back to that initial conversation about we're focusing here on being a mathematician, not being in math class. There's a difference there, right? The resources I have for you, all of these are hyperlinks. So when you download this presentation, you can use all those. You'll see if you are interested in the Stubitizing cards, those are all under the suggested activities, along with like the 3-act math test that I had talked about are over in the professional development resources. So we have a few minutes. The presentation link is right there listed out for you. You can also go back to the initial page and click on download the resources from this section, and that will take you to the spot where you can download the presentation. But at this time, we have 3 more minutes. Is anyone interested in any questions or anything like that? While you kind of think about that, I am going to get the 2 links for the, hold on 1 second, evaluations for you to consider. This is the ISB evaluation for you. And then the second one is the presenter evaluation. And my name again is Lindsay Herlihy, and this is Young Mathematicians. Keep back to our presentation. All right. I also want to put up here my contact information if you're interested in further discussing any of these resources or anything along those lines. You have my contact information. Thank you, Brittany and Kate. I'm glad you appreciate it. I'm glad that you hopefully found something to take back. Always looking for something when we attend these sessions. All right, so there you go. Thank you again, everyone, for being here and for joining us today. And we will see you later today. Sarah, I'm happy to see you.